please welcome Promersion's CEO, Rolf Brink.
So, hello everybody. My name is Rolf Brink. Many of you will know me as the project lead for immersion within cooling environments. And although today is actually a bit of a special day, we come with a bit of a celebration. It's almost to the date 5 years ago that we had our very first public immersion community call. And it's not just for immersion, the whole of cooling environments. About 5 years ago that we kicked off the cooling environment solutions calls. So this OCP work is something that I do voluntarily, just like all the other work stream and project leads that we have, which is a lot of them, and they put up a lot of work. I actually make my living running a consultancy firm, Promersion. And as part of my day-to-day activities, I'm very often, slide behind. I'm very often confronted with some similar questions. Questions like, hey, which cooling technology is going to be the technology that we need to invest in? Or who will be the winner? Which cooling strategy can we use to scale out our next generation chips? And this is something I would like to get into today with all of you. And to do this, I need to take you guys a couple of years back to a time where all the data centers were pretty comparable across the board. IT equipment was pretty homogeneous, similar power trends across different platforms. And it's around 2016, 2017 that data centers started noticing some changes in the way that they could roll out their IT equipment and their server racks. And it's also clearly visible here on this chart. Rack density started increasing around that time. And this is something that has been echoed by previous speakers as well. The cause of this is the actual efficiency of the transistor density. The efficiency increases in transistor densities is actually not going as fast as it used to, right? And that is something that we can also clearly see with the trends of the chip densities over the years. There's a clear inflection point at around 2016 where chips started becoming hotter, started accumulating more heat, consuming more power. Even though the efficiency is still increasing and the core power consumption is going down still, the core counts are still increasing. Right? And especially if we're looking at the new chips that are coming out in the upcoming year, we're talking about the AMD Turin or the Intel Emerald Rapids or the B100 from NVIDIA. These are promising to have a significant impact in our thermal footprint. And this is why a lot of the ecosystem currently is so focused on liquid cooling. As you've heard from all the previous speakers, like Forrest, Zane, and Loy, that you've just heard from Intel and AMD and Marvel. Everybody has to deal with liquid cooling somehow. And there are different approaches to this as well. So if we're looking at the NVIDIA platform, which already came out 2 years ago, that's rated for 10 kilowatts. If we're looking at the next GPUs for next year, we're going up to 1 kilowatt per chip. So that box is going to do 16 kilowatts on the GPUs alone, not even looking at the compute on the rest of the components that are in there. So NVIDIA is approaching that with looking at two-phase cold plate solutions for the chips, for the GPUs, and immersion for the rest of the compute components in an enclosed chassis format. Cerebras, not sure how many of you are familiar with the company. They're making this huge wafer-scale chips, nearly 25 kilowatts in one of these chips. They have different challenges. They're approaching that completely differently with a single-phase cold plate approach. Storage systems, even the OCP storage system is now going up to the 2 kilowatts. It's already there. It's not a surprise that a lot of the storage manufacturers are actively looking at immersion, full immersion cooling, to cool these platforms. So that brings me to the different types of cooling that we're dealing with in this industry. We can group these in three main categories: door heat exchanger, cold plate, and immersion. And these also happen to reflect the main solution projects within cooling environments. And within these projects, there is a huge variety of technologies being represented. And the nice thing is, all these technologies have their own value adds. They're all unique in many ways. We're talking about indirect, direct, and total liquid cooling solutions. Whether we're looking at open bath or enclosed chassis, every one of these technologies comes at a specific challenge that the industry has experienced in a very unique way. And this is part of that growth of the market, and this is where it's really getting interesting. So we've heard from the previous speakers, we know that the solutions and the technologies out there, these are proven technologies. The industry itself is already growing. What we're seeing now for the liquid cooling industry itself is that this year marks a special milestone. The liquid cooling market, and I'm talking about cold plate and immersion by itself, is topping 1 billion in market value this year. And we're well on track on achieving that as well, right? And this is part of a larger movement in the market. It's driven by all these technologies. And one of the significant pivot points in the market at this point in time is the fact that cold plate as a technology is right now transitioning into commodity, which means that new server designs that are coming out of the factories, coming off the shelf, are now being equipped with cold plate technology, right? As part of the chassis, as part of the solution. And that is an incredibly exciting thing to see, because it's, first of all, it starts that momentum for cold plate technology, but it also normalizes the liquid cooling infrastructures within data center facilities. Immersion cooling has a few more challenges to deal with, right? So talking about standardization, material compatibility, the chemistry itself, but also usability. These things are difficult to deal with, but we're well on the way on mitigating these, on addressing these head on. And this is also underlined by the incredible uptake of participation in the immersion project within Open Compute. We're the largest project in Open Compute, and the advancements, the utilization of immersion cooling in the industry is no longer hypothetical. It's just a few years behind on cold plate. So if you compare today with immersion cooling with a few years back with cold plate, we're in pretty much the same boat right now. So what do these forecasts look like, and are these even credible? So we've run a lot of different scenarios for the market, and one of the key takeaways here is that the market growth is not a hypothetical thing. These technologies are a necessity. And that means that the basic scenario that we're looking at has an outlook of reaching a 10 billion market in 2030, with an annual growth rate, a compound annual growth rate of 37%, which is really, really good for any kind of market. But if we're looking at the volatility of this market, most of the scenarios that you can come up with relate to the adoption timeline of certain technologies. And a slight deviation in that, with the adoption timeline of some of these technologies, triggers a completely different model with a 20 billion market figure for 2030 and a growth rate of 52%. Right? So with this in hand, which technology is going to be the winner? Door heat exchangers, seeing that now in all the racks, are they going to be able to provide that precision cooling that we're all looking for with these higher chip densities? Cold plate technology, is it really feasible for every transistor or every semiconductor and every component that warms up on a board to equip it with a cold plate? Is it economically viable? Or immersion then? Single phase, two phase, enclosed chassis, open bath? Is it able to deal with the 2 kilowatt plus chips that we're going to be confronted with in a couple of years from now? Before we can really look into this, we're going to need to look at some other numbers again. Remember that homogeneous environment that we had up to about 2015, 2016, 2017? The world looks a little bit different today. This is an estimation of the amount of servers that are shipped per type of system. And one of the interesting things here is that more than 60% of all the compute that is shipped out from the factories actually relates to cloud platforms and general purpose systems. Now, let me ask you this. Do cloud-optimized and general-purpose systems actually experience the same challenges as that GPU-optimized system that's doing 10 kilowatt? And next year, even 20 kilowatt? What about the network equipment? What about storage? Are they all experiencing the same kind of challenges? This landscape is a lot more diverse than it used to be. And that means that we need to look at this landscape differently as well. We cannot just pursue that single solution. So before we can evaluate these kind of technologies, we're going to have to identify whether we're approaching this from, let's say, a chip manufacturer point of view or an end user. A chip manufacturer is aimed at the highest possible performance or thermal density of a chip of your highest product, and what it will be in a couple of years from now. That is a challenge you're solving as a chip manufacturer. But an end user is dealing with a lot more challenges, a lot more elements in that evaluation. And that all starts with the application. What does the application need? Because that turns into a set of compute requirements. And that turns into a selection of IT equipment, IT hardware, different types of hardware, storage, a combination of storage, networking, different platforms that facilitate that one application that you're running. Then you can mix in the facility environments, the facility requirements, or even the business goals. Are you just aiming for pure performance, or are you aiming for a highly sustainable environment? Certain sustainability goals. It makes a lot of difference whether you're trying to deploy an AI platform in Mumbai or in Canada, or whether you're aiming to roll out your cloud-optimized platform in India or in Singapore or in Northern Europe, and you would like to implement free air cooling. It really makes a lot of difference. So that means that we can ask this question, basically, can one size fit all these technologies? And the answer is no, it cannot. But there's a few things that we do know, and that is this. Over the next 5 years, every data center in the world will have to deal with liquid cooling in one way or another. It doesn't matter which, but you're gonna be dealing with liquid cooling. Air cooling will not disappear. Absolutely not. A majority of the platforms will still be fine with air cooling. But we have to recognize that not a single technology will be or should be dominating the entire landscape. So what is it that we should do, or how do we move forward with this? Well, it really starts with setting up a unified liquid cooling infrastructure, an infrastructure that can facilitate all these technologies alike, whether we're talking about air cooling or liquid cooling. Honestly, that pipe outlet on a water pipe, on a water distribution system, shouldn't really care whether it's connected to an air handler or one of the in-row coolers that we're going to see here on the floor as well, or whether it's connected to a cold plate or an immersion system. For that pipe, that shouldn't matter. What really matters is that you can diversify your environment to your platform's needs, because that's what's going to give you the flexibility that you're going to need across the industry. And as an industry, we, especially here within OCP, will have to focus on the interoperability of these technologies to make sure that these technologies can collaborate together, can jointly be deployed within the facilities. And that provides you with a multi-generational approach to cooling technology that future-proofs your facility. And it also puts you in a position where you and your customers can be completely technology agnostic. And this is a daunting exercise, of course. This is why Sandeep Ahuja from Intel, Tim Shedd from Dell, and John Gross from JM Gross Engineering, and myself have come together and decided to author a paper to help the industry make these kind of choices, to provide guidelines for this, to provide some advice on how to approach this. And obviously, this will be run through the cooling environment structure that we have in OCP. But for now, I just want to leave you with this. Brace for change. Please start engaging with the liquid cooling projects within Open Compute. Prepare for these liquid infrastructures in your facilities or with your technologies that you're developing, and start evaluating them. Get familiarized with all the pros and cons of every technology that's out there, and discover the power of combining them. Have you really thought yet about potentially putting a cold plate inside immersion? Have you thought of cascading thermal energy across multiple solutions? Try and figure out these values, and stay tuned for the new paper to help you with your needs. And for now, I want to say thank you, and I hope to see you all in the engineering tracks in the coming days. We're looking forward for a lot of excitement. Thank you.